Hey everybody, welcome back to Gideon Stuff and welcome to another episode of Gideon Stuff Adventures. I'm really excited about this one. We're in the garage again. I know it's not the most exciting backdrop, and some of you might wonder why I do this in the garage. It's because this is where I can be the least obtrusive to my roommates. So maybe I should throw up something in the background. I don't know. I do have a bunch of my rocks here. I do a lot of projects in the garage. I think I've pretty much commandeered it from my roommates. Anyways, that's why we're always in the garage. Today's video is really exciting, and this is kind of a special one for me because today we're going to the Organ Mountains, and specifically we're climbing Organ Peak and taking a look at the Organ Summit Observatory. The Organ Mountains are probably the most recognizable mountain range of southern New Mexico, and honestly probably one of the more famous and recognizable mountain ranges from New Mexico in general. They are truly S-tier mountains. You look at the Organ Mountains and you just go, damn, those are mountains. They look like if you were to ask a kindergartner to draw mountains. Just jagged spires stretching up into the sky. It's wonderful. The mountains are kind of the symbol for the city of Las Cruces. You see iconography of the mountains everywhere. Logos for businesses, decorations on cars, tattoos. If I were to ever get a tattoo, the Organ Mountains would be high up on my list of things to get tattooed. They're just beautiful and wonderful. They look like the ridge, the sail of some huge monster rising up out of the desert. It's like Godzilla swimming through a sandy ocean. They are beautiful, they're stunning, and they are a very popular destination for hikers and climbers of all kinds. The most striking feature of the range are the quartz monzonite spires that form the needles, as they're called. In fact, the high point of the mountain range, Organ Needle, is one of these spires, and that sits at an elevation of 8,982 feet. However, Organ Peak, you might expect to be the highest peak. It's not. It's a sub-peak just south of the Needles, and it's at an elevation of 8,872 feet. It is much less frequented, and as such, very attractive to me as a peak bagger. I have climbed Organ Needle. It's a strenuous but very rewarding climb with a fairly serious rock scramble to get to the very top. But everyone has done the Needle. Maybe one of these days I'll make a video about climbing the Needle. It's been about 3 years since I did that climb, so might be worth doing it again. But everyone does it. Everyone climbs Organ Needle. I have a bunch of friends who are also peak baggers who specialize in mountains of the Southwest. And there's 6 of us that I talk to kind of frequently. Of those 6, 3 of us have now done Organ Peak. Everyone has done the Needle at least twice, except for me. I've only done it once. Organ Peak is just kind of overlooked, which is kind of a shame, but it's understandable because it is not as striking or dramatic as the Needle, and it does sit at a lower elevation. However, that does not mean it's any less of a challenge to get to, nor is it any less rewarding than getting to the Needle. The other reason that I really want to bag this peak is because there's an observatory out there near the peak, and we go to both of those in this video. And the observatory was kind of our main goal for this hike, but we were going to bag the peak, just while we were doing that, and we were able to accomplish both things. But before I move forward with this video, I want to give some words of wisdom to you guys. The Organ Mountains are incredibly rugged and unforgiving. They are no joke. If you're going to be doing any of the more extreme hikes or backpacking trails through the Organ Mountains, I highly recommend that you do not do it unless you are an experienced adventurer with proper gear, proper training, and honestly, proper endurance. These mountains are not for the faint of heart. You will see signs out there all over the mountains because it's part of the Organ Mountains National Monument, warning you to be careful in these mountains because people have died out there. I personally know several people who have had to be rescued from the Oregon mountains and a couple who have died out there. There's a lot of dangers. The mountains are incredibly steep and rocky. Some of the slopes are made out of a very loose talus, so falling is a very, very real risk, and most falls out there are pretty fatal. The other thing is the environment is just really, really rough. The Oregon Mountains rise about a mile above Las Cruces. That's a huge, huge difference. You change altitude very quickly as you're climbing through these mountains, and the biome that you're in changes as well. And with this comes changes in air quality, changes in temperature, and changes in wildlife and plant life. All of this can be very, very strenuous and difficult to work with. I have known people, and I've heard stories and experienced myself, of hikers who have gone out into the Oregons, and you start early in the morning. Let's say it's winter or springtime. You get a nice early start, and it's a crisp 45, 50 degrees. As you start up the mountain, you're coming up let's say you're coming up the west face of the cliffs, the sun's coming over you, and all of a sudden, bam, it's 95 degrees. And then you drop down to a little canyon, and it's so shady that bam, you're back down to 60 degrees. This kind of temperature fluctuation in these hills can be deadly. You work up a sweat, you're hot, your body's just drenched, and then you go into a cold area and your body cools off way too quick. Or it's really, really hot, so you don't wear enough clothing, and then you get cold because you're out there too late, and when it gets dark, that temperature plummets as well. The other problem that people have is they'll start in the morning, it's cold, they put on a lot of layers. By the time they're out in the mountains, it gets too hot. Layers got to come off or you overheat. It's a very, very serious problem. I already talked a little bit about the elevation gain. Yeah, you go from 5,000 feet to about 9,000 feet in the course of your day. You've got to be pacing yourself appropriately. You've got to be dressed right. You've got to have the correct footwear. Make sure you've got food, water. Keep yourself energized because it is really, really strenuous. These mountains are unforgiving. They're rugged, they're rough, they're untamed. Not to even mention the wildlife out there. Cougars and bears. I've never seen a bear out there. I've heard reports of bears. More common is mountain lions. I run into a couple mountain lions out in the Oregons. I've known other people who run into some mountain lions. They're out there, and they are known to attack people in this area. So just be careful, and if you're going to be doing an adventure in the Oregon mountains, make sure you're prepared for it. Work up to it. Don't just jump into something like this. The Oregon mountains demand an experienced adventurer. So that is honestly the very best advice I can give before getting into this video. So let's go ahead and talk about the mountains themselves. The Oregon Mountains is part of a very long chain of mountains that stretches for about 150 miles to the north and the south. This chain of mountains includes the San Andres Mountain Range to the north, the Oregon Mountains in the middle, and the Franklin Mountains of southern New Mexico and West Texas to the south. Now, while all of these mountains were uplifted by the same tectonic event, and in fact, there's a huge normal fault that runs the entire length of this mountain range, and if I'm correct, I've heard other people say this, it is the second longest active normal fault in the United States and possibly the world, coming in second place after the Wasatch Fault of Utah, which is, I think, 210 miles long, or maybe kilometers. I might have to double check that. Anyways, this huge fault system is related to the Rio Grande Rift. I know, we've talked about that a lot. And even though all these three different mountain ranges are shared, or all three of these mountain ranges share this fault, they're very different when it comes to their lithologies, and that's why they're split up into these three distinct ranges. The San Andres Mountains, which I love, I've done field work out there, consist of a lot of Paleozoic sedimentary rocks sitting on top of Mosetsol Proterozoic rocks. The Organ Mountains are primarily volcanic rocks, igneous rocks, both volcanic and plutonic. Got my words mixed up there. And the Franklin Mountains are primarily sedimentary rocks from the Paleozoic as well, mainly limestones. We're not going to talk a whole lot about any of the rocks exposed in the Organ Mountains besides the igneous rocks, but I will touch on some of the other rock units really quickly right here. There are technically very, very old Proterozoic metamorphic rocks and granitic rocks exposed in the Organ Mountains. There's not extensive exposures of these rocks, but they are out there, and these range from about 1.4 to 1.6 billion years old. So these are among some of the oldest rocks in New Mexico, and these are left over from different craton building events, probably island arc accretions. These are from the Mosetsol orogeny, as well as probably the Picaris overprinting and some different orogenies like that. We're not going to get too much into that right now. The other rocks are going to be Paleozoic sedimentary rocks. Again, mostly limestones from these huge empiric reef systems that dominated this part of the world back in the Paleozoic. We are going to talk about these rocks in a little more detail as we go on, but mostly in the way that they relate to the more important rocks, the igneous rocks. The Organ Mountains are actually the leftover remains of a series of calderas that were active about 36 million years ago. The Organ Mountains actually represent the very easternmost extent of the Mogollon-Datil volcanic field. This is a very important geologic province in western New Mexico and a little bit of eastern Arizona. Basically, it was a series of very large volcanic eruptions that lasted several million years. This was related to probably slab rollback from the Farallon Plate going underneath North America. That's what caused the Laramide orogeny that built the Rocky Mountains. And then after that slab started to fall into the mantle, it opened up a lot of space underneath the crust. You had some extension going on. When you start extending the crust, you thin it. And thinning the crust means that it's easier for magma to get from the mantle to the surface. What's that called? Volcanism. Tons and tons of eruptions. The Organ Mountains are split into three main groups when it comes to the rocks. The northern part of the mountains include intrusive rocks that are similar to granite. Most of these are quartz monzonite. The middle part of the range is more of the extrusive rocks, primarily rhyolite, which is the extrusive form of granite. We'll talk about extrusive versus intrusive here in a little bit. And the very southern part of the range has limestones and tuffs. So these limestones are Paleozoic rocks, very similar to rocks exposed in the Franklin Mountains, and the tuffs are related to these other volcanic eruptions. Most notably, this would include like Bishop's Cap, which I've made a video on Bishop's Cap. It has a sequence of Paleozoic, actually a complete strata of Paleozoic rocks all the way from the Cambrian to the Permian. Some people don't count Bishop's Cap as part of the Organ Mountains. Some people say that the Organ Mountains end at Peña Blanca, and that Bishop's Cap is just kind of its own little thing in the Anthony Basin, which is this big stretch of fairly flat land between the southern end of the Organs and the northern end of the Franklins. Depends who you ask. Some people include Bishop's Cap with the Organs. I'm kind of neutral on it. I could go either way on where you want to include it. But yeah, again, our volcanic rocks and our intrusive rocks are going to be the most interesting parts of the lithology that we talk about today. Okay, so I keep throwing around some words. Intrusive, extrusive, volcanic, plutonic. What do these words mean? These words refer to where a magma cools, or a lava. Magma is molten rock. This is where we get basically all rocks from. They start as a rock soup under the surface. When this magma erupts onto the surface, it becomes lava. When this hot liquid cools, it becomes different kinds of rocks. If this hot liquid cools underground before it has a chance to erupt to the surface, we call this an intrusive or plutonic rock. And if it cools above the surface after an eruption, we call this an extrusive or volcanic rock. Kind of makes sense. Volcanic eruptions, right? How do you tell a difference? Because the only thing that's changing is where it cools, right? They're compositionally the same thing. Yes, exactly. If you have a magma that has a high silica content and it's made up of the ingredients to make quartz and feldspars, you're going to have a granite if it cools underground and a rhyolite if it cools above ground. Same composition. The difference is the texture. See, if a rock cools underground in a magma chamber, it cools very, very slowly. Rocks are excellent insulators. So if you have this little, you can think of it as like a bowl of lava under the surface, it's going to lose heat very, very slowly. And as it's losing heat, it's going to start to crystallize. That's all a crystal is a liquid that has become solid, right? That's what it means to crystallize. So as this magma cools, crystals start to grow. This happens because when the magma is hot, all the atoms, all the elements in there, they're buzzing, they're vibrating, they can't form bonds. As it starts to cool and lose energy, atoms start to move slower and slower, and then they can form bonds, and they can build into crystal lattices, and those crystal lattices build into crystals, and those crystals build into minerals that build into rocks. So the longer it takes to cool, the bigger your crystals get. And so these intrusive rocks have what we call a coarse-grained or phaneritic texture. You can see all the crystals with your naked eye. They're big and chunky and interlocking. On the other hand, if this magma is erupted as lava to the surface, it cools very, very quickly. The surface of our planet is pretty dang cold compared to the rest of the planet. You might think here in the Chihuahuan Desert that it's hot when it's 110 degrees outside. That ain't nothing on the subsurface, right? When rocks get to the surface, they cool incredibly quickly. What happens when a rock cools very quickly? It doesn't have time to grow big crystals. Instead, it grows little tiny crystals, and in the case of some volcanic rocks, it forms crystals that you can't even see unless you really zoom in and magnify that rock. We call this an aphanetic texture or a fine-grained texture. So that's the difference between a rhyolite and a granite. A granite has big, chunky crystals because it cooled slowly underground. A rhyolite has tiny, fine-grained crystals because it cooled quickly above the surface. As I mentioned, the Oregon Mountains preserve 3 separate calderas. A caldera is a huge area of land that is basically the collapsed remnants of a magma chamber. Famous calderas include the Yellowstone caldera or the Valles caldera in northern New Mexico, which I've already talked about. Basically, when you have a bunch of magma under the surface, this gets complicated. The geophysics of magma chambers aren't understood that well, so I'm going to really, really simplify this just for the sake of explaining. Basically, you have this big hollow. If there's any geologists watching, they're going to be like, well, actually, I know, I'm kind of simplifying this, but you have this big area, this big chamber that's full of magma. As you're erupting through vents to the surface, the magma in your chamber is decreasing. The other thing decreasing the magma in your chamber is the fact that it's going to be cooling along the walls. So you're slowly going to start getting a smaller and smaller puddle of magma, you can call it. And sometimes you'll have a really big eruption that takes a lot of that magma out of the chamber all in one go. Well, this destabilizes the entire system. And a lot of times what happens is the ceiling will collapse down into the chamber and you're left with this big depression. That's a caldera. It's essentially an empty magma chamber that has collapsed in on itself. The Oregon Mountains preserve 3 of these events. And because these are very destructive events, it's kind of hard to study any of the calderas except for the youngest one. And even then, the youngest caldera, there's still research ongoing, and people trying to figure out everything there is to know about this eruption. But these 3 different eruptions were absolutely massive. These would have been like civilization destroying eruptions in the area at the time. We're thinking stuff like Yellowstone. And actually, interestingly enough, there is a rock unit exposed out here in the Oregon Mountains. It's a very young unit. It's from more recent history, about 1 million years ago. It's called the Camp Rice Formation. And there's actually some sediments in this formation. It's mostly conglomerates and sands. That is like a very fine layer of ash. And that ash has been traced back to one of the Yellowstone eruptions about 1 million years ago. So that gives you a sense of scale for just how much material these super eruptions can expel. Yeah, we've got material from the latest Yellowstone eruption down here in New Mexico. And of course, you're erupting out all these rhyolites and all these tuffs. And then below the surface, you're cooling your magma into granite. So after some time, the magma in this system was pretty much depleted, and the caldera collapsed on itself. And this happened 3 times at least. Later, the rocks that were under the ground, remember, we still have all these big granites that have cooled under the ground, are uplifted when the Rio Grande Rift starts opening. Rio Grande Rift starts opening, the rocks around it start to fault. You have this huge chunk of granite under there. It's pretty resistant. It gets pushed up to the surface and becomes exposed as the Oregon Mountains as we know them now. The needles are made out of a quartz monzonite, which is part of the Oregon Mountains batholith, which is essentially this huge chunk of granite sitting out there. The stuff that you see exposed in the Oregon Mountains, those spires that are thousands and thousands of feet tall, that's just the tip of the iceberg. You go down further, and that shit goes forever. It's like a huge iceberg. This is a big old chunk of rock. However, Oregon Peak is not part of this. Oregon Peak is actually composed primarily of some of these erupted rhyolites. Now, I have a confession to make. I am not exactly sure what rocks are out here at Oregon Peak. There's a couple of different tuffs in the area. The La Cueva tuff is probably the most famous. There's huge chunks of this exposed kind of towards the valley floor at the La Cueva campground there for the Oregon Peaks. And then my favorite piece of La Cueva, which is out to the south, just kind of nearby Bishop's Cap. It's called Peña Blanca. Huge chunks of this tuff. There's also the Squaw Mountain tuff. Or actually, I think Squaw Mountain was renamed to the Bar Canyon tuff. The Soledad Canyon tuff. There's a bunch of these rhyolite units out here. I'm not sure which one Oregon Peak is made out of. When I was out there climbing the mountain, I remember looking at the rocks and I picked some up and I was like, oh, okay, so this is rhyolite. But I'm also pretty sure that I saw some cyanites out there, or quartz monzonite, like the spires, especially on the ridge going up to the peak, which you guys will see here in a little bit. But for the life of me, I cannot remember exactly. This is why geologists keep really good field notes, because you will not remember what you see in the field when you get back home. You just won't. And on the day that I climbed this, I was exhausted. I was tired. It was a bitch of a climb. I saw the rocks. I remember saying out loud, I think this is a cyanite, to Janelle, my climbing partner. I might even have it in the video that I'll show you guys. But I don't know if I was right on that or not. I saw cyanite. I think I saw some quartz monzonite. But I didn't take any pictures. I didn't write anything down. I also didn't take any samples or anything. So that's kind of frustrating to me. I've been looking at geologic maps, and I have this map in this book right here that very helpfully points out Oregon Peak. And right there, it says that it is in pre-caldera rocks, which is super helpful. Not I'm not sure exactly what it was, but it is a separate. It's not the quartz monzonite that makes up the spires. And one of the ways I can tell that it's actually a separate rock unit is just by looking at the mountains from the bottom. Generally, the granites erode into more jagged shapes than the rhyolites. The rhyolites will erode into these big humped features. And so when you're looking at the Organ Mountains, again, you'll notice to the north, jagged spires, and you'll notice kind of towards the south, more rounded mountains. And Organ Peak is one of these more rounded mountains. So definitely probably primarily rhyolite, but I'm pretty sure I saw some other stuff on the ridge going up there, and I'm kicking myself for not taking better notes. I really should have. It's a big oopsie on my part. One thing I do want to mention is we already touched on some of the Paleozoic rocks in the area. I said we'd come back to those. Here's where we're going to be coming back to those. The Paleozoic rocks, a bunch of these limestones, were actually the caldera walls. So when the magma intruded into the crust, what it was intruding into were these Paleozoic limestones. And so you have the magma working its way up to the surface. It's cutting through all this limestone. Eventually, the magma chamber collects and builds in this limestone. And we have this really interesting phenomenon going on called contact metamorphism. This happens when a hot rock cuts into or gets basically put next to a different rock and essentially bakes it. When you do this to limestone, you form marble. So when you're going to Bishop's Cap, or not Bishop's Cap, you're going to the Organ Mountains, you might take a look at some maps and you'll see that there's a lot of mines in this area. And a lot of these mines were located towards the lower sections of the mountains because they were looking for that contact between the limestone and the granites, because you had a lot of mineral-rich deposition of economic materials going on in this area. There was some marble mined out of here, but the marble's really hard to get. To find the marble, you gotta go to exactly where the limestone and the igneous rocks meet. It's beautiful. I was out at a friend who has some land around there and stuff, and I actually picked up a piece of marble. I've got it right here. Let me grab that. So here's some marble from the Organ Mountains. And this was formed when the intrusive igneous rocks started cooking the host limestones. And there's a lot more that we can get into with that, but that area is pretty incredible, and it's very possible. I didn't see any of this on the trail going up to Organ Peak, but if you were to look around this area, you definitely cross over that transition from the marble to the igneous rocks, and it's pretty freaking cool. I also really quickly want to mention that Organ Mountains are well known for producing some of the very best feldspar crystals anywhere in the world. Feldspar is a very common mineral. In fact, I've got a bunch right here somewhere. Let me grab where's a good piece? Now we'll grab this. So this is a piece of a pegmatite. And this is a 1.6 billion year old pegmatite. But we can see here we've got some muscovite mica. We've got this huge piece of quartz. And then you see this big blocky square mineral right here. There you go, catching the light a little bit. That is a big chunk of orthoclase. If we look over here, you can see more of these chunky, they look like these little bricks, these little squares. Those are also orthoclase feldspar. Feldspars are very, very common. They are one of the most common rock building minerals. And a lot of times, I love feldspars. Those ones are some good ones that I showed you. But a lot of times, they're kind of plain minerals. The Organ Mountains have produced some just beautiful, excellent quality orthoclase. And in fact, I have seen orthoclase crystals from the Organ Mountains in geology textbooks. And one of my favorite fun facts is if you go to the Wikipedia page for orthoclase, they have a picture of orthoclase from the Organ Mountains. So I think that's kind of cool as a rock nerd. Not sure if it's useful to you guys, but I thought it was pretty freaking dope. Alrighty, so without any further ado, let's go ahead and get this adventure started. I will be interrupting at some point in the video, though, to talk about that observatory. Hey guys, welcome back to another Gideon Stuff adventure. Today, we're going to be going into the Organ Mountain, specifically climbing Organ Peak. And, well, Organ Peak is actually probably going to be a bonus. The main goal of this adventure, I guess, is to get to an old observatory that's up in the Organs. I'm waiting for Janelle to get here right now, so figured I'd give you guys a little bit of backstory. So I've known about this observatory for a while. Always wanted to go there, never have, and so we decided that we're gonna do it. If you look on Google Maps, this observatory is labeled the Corralitos Observatory, but it's not. We got interrupted by Janelle calling me. She's turning in right now. Where was I? Corralitos Observatory. This is not the Corralitos Observatory. This is, I actually don't know what it's called, but the Corralitos Observatory is actually to the west. It's out in the Rough and Readies. So that is incorrect. However, there was some equipment, I think in the 70s, some equipment was taken from an observatory at Organ Pass and taken to the Corralitos Observatory. So that's, I think this is that one. However, I've also heard people say that this is associated with Fort Bliss, military observatory, which it could be, for sure. We'll see, right? When we get up there, we'll see. I'll do some more research and see if I can figure out some more information about this site, and I will throw that in the video. And here comes Janelle. It's her birthday today, by the way, so this is kind of a birthday hike, so we'll be sure to wish her a happy birthday when she gets here. All right, so this is officially the start of the trail. We're gonna be hiking the Fillmore Canyon Trail for a while here at the La Cueva site. What was I gonna say? We took a little bit of a scenic route to get here because we're crazy.
We want to pay $5.
Yeah, and so we won't have to pay $5 because we're cheap too, I guess. But now we're on the official trail. We're gonna follow this for, a mile or so to the head of the canyon, and we're gonna kind of jot off to the right. People have died while climbing these mountains.
They'd rather take too long, they'll leave you alone.
You think we have the ability and the equipment and the time to accomplish this? I think so too. Let's do it.
We need a cook to the ground.
couple of notes about the geology of the area. Things like the cueva over here, these are volcanic rocks. These were erupted between about 35 and 15 million years ago. The high peaks here, well, actually a lot of that stuff's also extrusive, but the needles in particular are intrusive granitic igneous rocks. And so they're actually, get around this bush, they are the remnants of a magma chamber that sat in a big caldera here, the Organ caldera. And so these cooled underground, slowly developed large crystals, and then they were uplifted during Rio Grande rifting. You can actually see they were intruded into limestones from the Paleozoic, and at that contact between the limestones and the igneous rocks, you can find marble, which is a metamorphic rock formed when you heat up limestone. So that's pretty cool. All right, so just before you enter the canyon, just a little ways before the Modoc mine, you're gonna get off the main trail and get onto a social trail. But there are a couple of mines all over this area, and there are a lot of trails going every which direction. Some of them are people trails, some of them are probably javelinas, but it's easy to get sidetracked. Starting to gain some elevation. This is Fillmore Canyon, right in here. Whew. Climb pretty fast. Alligator juniper. Well, there's our first official look at Organ Peak while on the trail. I almost said trailer. This is the canyon, Fillmore Canyon still. There's the needles. And that right there is Organ Peak. And the observatory is somewhere over there.
Did you notice my birthday?
I did. Here's the birthday girl. Happy birthday, weirdo. Oh, beautiful out here. She says to send her rocks in the mail. You want fluorite?
To the fluorite. I already have answers. Oops. Okay.
So for any of those of you that have my mailing address, you can send me birthday rocks for this thing. Well, we're up around 7,000 feet, getting there. The plant life, the flora, has changed quite a bit Still got the desert plants. There's a cholla, a sotol, but we're seeing a lot more juniper. Seeing some currant bushes, stuff like that. I imagine we'll see some pine trees in the saddle going up to the peak. Actually, as soon as I stopped recording, turn the corner and look. There's a big old ponderosa.
Ponderosa pine.
Ponderosa pine. I think so too. This is a great spot. So right now, we're coming into an area called the Narrows. It's gonna be this little passage between these cliffs on either side. Should be pretty gorgeous. Uh-oh. This has been here for a long time. Feel how many butts have slid over that. Wow. Isn't this gorgeous? Wow. So, right here, we got something interesting. The foot of this big ol' alligator juniper. There was a plane wreck here in the Organs. When? You just knew stuff. I don't know when the wreck was. I can't remember. But yeah, you can find pieces of airplane lying around. I guess he just really wanted to. Well, there's the observatory up there. That's the organ needle. It's a high point of the organs. And Janelle and I were just discussing how the hell did people get the building materials up here? Because that's not easy coming up that. Delightful. She's on a mission. Oh no! We can't get in, it's locked. Oh, never mind. I guess the answer for how this got built up here is if Uncle Sam wants something, Uncle Sam has the money to make it happen. So that's White Sands Missile Range. There's White Sands, the sand. If we zoom in, there's Sierra Blanca. Those are the Sacramentos. Right here, the San Agustin Pass that separates the Organ Mountains from the San Andres. San Andres go like that. Dolorosa Basin out there. This way, there's Cook's Peak. We climbed that last week. Pretty awesome. See out the Robledos, Picacho, Sierra de las Uvas, Rough and Ready's. There's the Floridas, Tres Hermanas. You can see a little bit of everywhere. That right there is Organ Peak. That's Organ Needle. Okay, let's talk about that observatory. If you look on Google Earth, Google Maps, or even just like do a cursory research on the fact that there's an abandoned observatory out in the Organ Mountains, most places will tell you that it's called Corralitos Observatory. It's not. That's bullshit. The Corralitos Observatory is west of Las Cruces, not east. It's out in the Sierra de las Uvas, well, technically the Rough and Ready's, or the Sleeping Lady Hills, which Sleeping Lady and Rough and Ready's are kind of the same thing, depending on who. Anyways, naming mountains is weird. I've been to the Corralitos Observatory. It's called the Corralitos Observatory because it's named for the Corralitos Ranch, which it's on. The Corralitos Ranch is west of Las Cruces. I could not find any information on this observatory. I asked some people I knew. The most that I could get out of anyone was people were saying, oh yeah, it's probably an old White Sands observatory. Oh, it's probably an old Fort Bliss observatory. When I was out there at the observatory, I agree. It looked like it was built probably by the Army. Is probably from White Sands or Fort Bliss. Fun fact, technically speaking, Organ Peak is in the White Sands Missile Range, but it's kind of just a technicality. You're really not supposed to be on White Sands Missile Range without, proper permitting and an extensive background check. But this is way up high in the mountains. I don't think they really check on you up there. So that was all I could find out about this stupid little observatory. Well, then I did some research, and I found what I think is the answer. In fact, I know it's the answer. I didn't find a whole lot on the observatory itself. I didn't find any, basically talk about its history, when it was built, who built it, this, that, and the other. But I did find a mention of it in an old NASA report. The report is from 1976, and it's called the Corralitos Observatory Program for the Detection of Lunar Transient Phenomena by Northwestern University. And it was written by J. Allen Hynek, J.R. Dunlap, and Elaine Marie Hendry. So shout out to them. I'm sure they were awesome. It's about the Corralitos Observatory, right? Feels like I'm going in a circle, but no. No. Let me read you from the first page of this document. They're talking about getting the funding for this project, getting all the tools together and everything they needed to do to launch this moon observing research. Quote, it was originally planned to locate it would help if I could read. Quote, it was originally planned to locate the telescope at Organ Mountain Station, New Mexico, where Northwestern's observatory was located. However, inability to acquire the necessary additional land, coupled with increasingly adverse observing conditions, such as lights at the White Sands Missile Range nearby, led to the search for a more suitable site. The site chosen was on federal land in the Corralitos Ranch near the intersection of the Sleeping Lady Hills and the Rough and Ready Hills, approximately 21 road miles from Las Cruces, New Mexico. Initial tests of sky darkness, wind velocity, weather conditions, and quality of stellar seeing disks indicated that the Corralitos site was superior in each respect to the Organ Mountain Station site, not only for this new program, but for other astronomical applications. I think this right here is exactly where the confusion on labeling this observatory the Corralitos Observatory came from. I imagine that Northwestern was using this observatory for a lot of research that then got moved to the Corralitos Observatory when it was deemed no longer ideal for that kind of research. And the Corralitos Observatory has been used for some really, really awesome research over the years, although it has been retired as well at this point. Awesome. We have a name for this observatory. But what happens if you Google Organ Mountain Station site? I Googled that. Not a whole lot of helpful stuff came up. So I Googled Organ Mountain Station site observatory. The first result that comes up, the Wikipedia page for the Corralitos Observatory. The other thing that comes up is the Clyde W. Tombaugh Observatory, which is at New Mexico State here in Las Cruces. I've also been to that observatory. But that's not in the Organ Mountains. Then you see some stuff about, here's some Reddit posts. Here's an NMSU astronomy post about the Organ Mountain peaks. Blah, 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 blah. Something about space tourism. The Organ Mountain Desert Peaks National Monument BLM page. History of the Sunspot Solar Observatory, which is all the way in Alamogordo. But then you scroll down, and you see Organ Mountain Station observational logbooks published by who? Northwestern University. Ladies and gentlemen, I think we're on the right track here. All right, so let's visit that site and see what we can learn. Here we are quoting from the Northwestern Library's Archival and Manuscripts Collection site. This series is comprised of 4 logbooks from the Organ Mountain Station of Northwestern University's Dearborn Observatory. Also known as Southwest Observatory, the station was located at Organ Pass, New Mexico, and was dedicated on April 7, 1961. It served largely as a development center for enhancing telescopic imagery and received funding from the National Aeronautics and Space Administration. The logbooks date between August 22, 1961 and October 26, 1965. Information recorded on log sheets typically includes name or initials of observer, observation date, identification of object or area observed, times of observation, weather conditions, temperature readings, and telescope and camera readings. Occasional remarks record weather changes and equipment or other problems that arose during observations. So this is really, really cool. I would love to dig through this stuff. However, I have not decided to reach out to the McCormick Library to request permission to read these documents yet, which maybe I should, right? Maybe one of these days I will even. We'll see. The one thing that kind of got me a little bit confused was it said that it was located at Organ Pass. Organ Pass is a weird term because, number one, you just don't hear it that frequently around the area. And number two, I've heard it used for a couple different things. One way that I've heard it used is for San Agustin Pass, which separates the San Andres Mountains from the Organ Mountains and is marked by San Agustin Peak. Some people call that Organ Pass. It's not. It's San Agustin Pass. There's also Baylor Pass that goes over the Organ Mountains, and I've heard some people call that Organ Pass. And so I was wondering, well, that's not super close to where this observatory is, so I might actually still have the wrong observatory. So, went to Google Earth to see if I could find anything about Organ Pass. Spoiler alert, I didn't find anything related to Organ Pass on Google Earth. Not that I was super surprised. After all, they have this observatory marked as Corralitos Observatory. They don't really know what they're doing. However, there did look like there was a road that at some point accessed this area, and it seemed to be a pass of some kind. If you're coming up from the northwest side, like Janelle and I did on this particular day, you're walking up Rockhouse Spring Canyon. Well, you walk up Fillmore Canyon, and it's Rockhouse Spring has its headwaters up there. On the other side of the ridge, that could be Organ Pass. I know that that ridge goes down and it kind of widens out behind Dripping Springs, and you've got like access there from Fort Bliss and White Sands. So it's possible to me that that could be the Organ Pass that they were talking about. Regardless, I am pretty solid, or I'm pretty confident in saying that this observatory is not the Corralitos Observatory. This is actually the Organ, what did they call it? The Organ Summit or Organ Station Site Observatory for Northwestern. So, mystery solved. Go me, I guess. Well, guys, we made it to the top of Organ Peak. Beautiful, beautiful views up here. You see all the way to El Capitan, there in Texas. There's the Franklins, also Texas. Man, this is beautiful. This big mountain here is Baldy, Organ Baldy. You know, I think that a lot of the old-timey explorers thought that it was like a rule that every mountain range had to have a Baldy, because I think every mountain range has a Baldy. I know it's a bald mountain, it's a great name for it, but come on, guys, be a little more original. And there's the needle. And this girl right here is fucking crazy. Climbing up here on your birthday? Just built different.
Sometimes on your birthday you gotta climb so far there's an organ needle just behind you and your head can block it when you go like this. But yeah, I like my birthday parties at 9,000 something feet, I think. The observatory is over there. They lied about how close it was, the little needle.
So I haven't been doing a whole lot of filming, but we're about to go into the Narrows on our way out. There's Organ Peak and also Janelle. So yeah, we've come quite a way down. But we're making much better time coming down than we did going up. There towards the top, it gets a little bit slippery. There's a couple of little scrambles. Nothing too major, but definitely gotta take your time. Isn't that awesome? I think I like it better coming in from this side. Holy cow. Sunday is for climbing mountains. Amen. Alrighty, so all in all, on this particular hike, Janelle and I went 15 miles. This was a 15-mile hike. It took us about 10 hours, 15 minutes. It's pretty serious. While there is not the same level of scrambling and rock climbing that is required to get to Oregon Peak, I would say that the hiking itself is just as strenuous. There's a section where just before you get to the Narrows, where you have to bushwhack through a pretty extensive swath of thistles and thorns, which can be kind of unpleasant. The final ascent up the Rock House Spring is pretty steep and can be pretty exhausting, pretty hard on your legs. And then the last little stretch to the top of the peak, you do have to do a little bit of trail picking. The trail is not really well marked. There is some minor rock scrambling and a little bit of climbing, but I would say it's worth it. And I really, really enjoyed climbing this peak. And I think it's a good one to do because it's not as frequented as the Needle. The Needle might offer better views, and there's maybe a better sense of accomplishment once you get to the top of that. But Oregon Peak is very solid and a really, really underrated mountain, in my opinion. Definitely deserves way more love than it gets. But that's going to be it from me today, folks. Thank you so much for watching. Big shout out right here to my channel members at Cowboy Level. I appreciate everything they do for the channel. If you want to become a channel member and support the channel directly, there's buttons down below. I'd appreciate it. And as for the rest of you hooligans, if you enjoyed the video, leave it a like, comment below, and subscribe. I've been Gideon, and I'll see you in the next one. Adios.